My name is Mollie Claypool, and I'm one of the directors of Automated Architecture, which we shorten to AUAR and pronounce as AUAR. AUAR is an architecture and technology studio and consultancy based in Bristol and in London. We started the studio in early 2019, although my co-directors and I have taught and worked with each other for over a decade. We are now 9 people with backgrounds in architecture, theory, product design, computer science, and software development, AR and VR, digital manufacturing, social justice, and activism. We are a spin-off of a research laboratory based at the Bartlett School of Architecture at UCL. The research lab, which we founded in 2017, was originally called Design Computation Lab. In September, we rebranded into Automated Architecture Labs as part of a concerted effort to more clearly develop a memorandum of understanding between our work in the studio and the research of the lab. This gives us a rather unique position where we can harness both the benefits of working in academia and in practice, and a lot of agility in how we apply our more experimental or speculative academic research in the real world. We deal with issues of social justice, including the future of work, platforms, localized manufacturing, and circular economies. We do this through work focused mainly on housing and on tool development. A core belief that we hold is in the potential of automation to provide greater access to design and making processes to more people. Now, housing in the UK is the most unaffordable it has ever been. New housing supply is dominated by 10 big companies who are failing to supply either the quantity or quality of homes that people want and need. So our work aims to enable greater democratization of technology and processes of making and architectural production. We believe that automation should not be centralized, but dispersed or diffused into communities. In our work, we wish to empower communities to take back power, to create the homes and spaces that they need, and provide both the social and technological infrastructure for this to be successful and sustainable for the communities that we are working in, creating and collaborating with those communities to create local jobs. One of our primary mechanisms for automating architecture is an approach, and some might call it a disciplinary project, that is referred to as the discrete. The discrete approach is a radical rethinking of the parts that make up buildings. Instead of architectural parts being constrained to types like column, floor slab, beam, or staircase, we think of them being made of parts similar to the zeros and ones in code. Now, this is based on principles of digital materials, a concept drawn from mechanical engineering. Digital materials have been defined by researchers, such as those at the Center for Bits and Atoms at MIT, as assembled from a discrete set of parts, reversibly joined in a discrete set of relative positions and orientations. What this enables us to do is reduce the number of different kinds of parts in a building, but also increase the capacity for spatial diversity, and therefore the ability of a discrete kit of parts to respond and adapt to the needs of local contexts without increasing costs or supply chains. Now, this is part of a framework for production that sits in critique of the notion of modularity. That's a result of the increasingly industrialized production processes of the 21st and 20th century. It's also a critique of the mass customization found in the digital architecture of the 1990s and of the early 2000s. Now, modularity at the scale of an apartment or a room unit, for example, does not enable the kind of universality that a single discrete part allows, in that the same modular unit cannot be used for all structural or spatial configurations. And while the parametric paradigm achieves near infinite variety, it requires costly and lengthy production chains. So the discrete uses the tools of parametric customization and serialized and modular mass production, but localized geometric differentiation. So we reduce building elements down to a highly reduced family of elements that can achieve multiple but finite orientations. Importantly, the discrete enables a scalability that neither paradigm can achieve. Higher or lower resolution is possible using the same combinatorial logic, in this case to construct a column and a floor slab. Now, what we see this doing is enabling an architecture that is entirely digital, Discrete architecture is architecture that is also perfectly made for automation. For example, digital fabrication technologies such as CNC milling work best when the same part or the same kind of part can be repeatedly cut out of sheet material instead of with customized parts, which also enables us to reduce a significant amount of waste. In this case, for our block type A discrete housing system, one sheet of plywood equals one discrete building block. Similarly, industrial or modular robots capable of building also really like repetition in assembly. They work best when they do the same or extremely similar tasks over and over and over, rather than having to be entirely customized in terms of their behavior or their tool paths. And we've referred to this in our work as the notion of discrete automation. Now, we're currently not alone in recognizing the capacity for architectural production to work better for automation. Architecture as a discipline, of course, was a relatively early adopter in terms of the design disciplines of digital tools, and there's a really rich history in architecture of taking on new electronic and digital technologies that dates back more than 50 years. Yet construction remains one of the least digitized sectors globally, with a significant automation gap, and it's only slightly more digitized than hunting. Furthermore, as many people watching this will know, construction has a significant labor shortage, and productivity has flatlined since the middle of the 20th century. Now, the automation gap is both the lack of innovative solutions in construction automation around changing social practices and a lack of innovation and creative thinking for supporting existing knowledges or trades within local contexts. And this has created a situation where technological innovation emphasizes the bottom line, and efficiency is favored over people's lived experiences, their knowledge, and their expertise. And what this results in is a huge amount of skepticism towards digital technologies within the communities most affected by increasing automation. And this is in the face of a predicted loss of over 680,000 jobs in the building trades in the UK alone by 2040. So we believe in AUAR that it's part of our responsibility to work with those people most at risk to find new ways to support existing workers and community members to discover new opportunities for themselves with technology. So we see discrete automation and its consequences on architectural labor as an approach for closing this automation gap. This then helps achieve a better streamlining of production chains, addressing what has been referred to as the assembly problem. And the assembly problem is the inability of existing approaches to automated or digital design strategies to reconcile effectively with existing building practices. Now, in our book, Robotic Building, published almost a year ago, we expanded on this, creating a larger discussion around what we called robotic building, putting it in the context of the age of automation. It also attempted to rethink the hierarchy of authorship. For us, it was an embodiment of our ethos as a practice in a lab, questioning the role of the single author. In the book, we defined robotic building as the utilization of automated technologies to realize architecture. But unlike research on automation that has occurred previously, this did not place robotic building only in the context of digital fabrication or digital design. We began to identify the impact that automation has had and will have for processes of production and architecture in the built environment, while also extending our argument towards new understandings of how relations between architecture and social practices might be transformed entirely by automation. So while the industrial robot arm is one such instantiation of automation and architecture that the book examines, the understanding of automation presented in the book argues for the dissolving of traditional notions of architectural syntax, an argument embodied in the discrete. Chapters follow themes such as craft, print, assembly, many, and diffuse, and include only realized projects led by the top researchers in robotic building internationally. So what we do in the book is recognize that digital architecture, the result of a more conservative and neoliberal approach to technology, has tried to play innocent in its fetishization of technological and formal innovation. But automation is not at all innocent. It immediately forces positions and questions about what increasing automation would mean for society. For example, do we all need universal basic income? Who owns robots? What jobs remain? What kind of housing will we live in? Will we all live in WeWork-like housing? Now, there are deep cultural issues within architectural production that really highlight the incapacity of our current disciplinary practices to adapt to these questions. Yet, when we use the term automation, architects are suddenly able, or really even forced, to think about these issues of labor, platforms, data, bias, discrimination, about jobs being lost in new kinds of rust belts, and about control and ownership. So we need to then rethink practice and how projects are delivered. In this case, our projects are homes. People live in them. When given the opportunity, it is evident that people do want to have some agency in how their homes are designed and made, not just how they live in them. People don't just want to have the choice about paint color and countertops. So we need to rethink the ways in which those in positions of power influence the way that the built environment is designed, produced, and lived in. Today, existing power structures must change if we are to shift to a society that can cope with the social, economic, and ecological changes that we as a culture and society need to deal with. So in AUAR, what we do is advocate for horizontal, participatory, and equitable social practices in architecture and technology, where individual autonomy and freedom of individuals is supported in a structure of care. And what we have seen is that this leads to more creative, inspired, and empowered people, and I hope more just built environments, homes, and communities. So how do we bring tools of production to people? How do we put them in the hands of people? How do we rebuild trust in such a striated industry? And how do we empower participation in a way that isn't extractive in terms of value or superficial in terms of meaning? How do we leave our I'm the expert, or I'm the one of all of the knowledge idea at the door when we work with communities? And how could decentralizing these tools into local communities really enable this to happen? And how does this augment and enhance local skills and knowledge? How can we radically rethink how these tools enable the best bits of previous paradigms and enable access to larger quantities of homes and quality design without adding significantly more cost? So what we do is we take an engaged scholarship approach, placing the values of the communities we are working with at the heart of our work. Now, engaged scholarship allows for the equalizing of power relations, of democratic practices, of situation-based action, mutual learning, tools and techniques, and alternative views about technology. And in AUAR, we anticipate increasing automation, but we put at the center the lived experiences of communities and understand that they hold expertise, that they hold knowledge, and understanding that we as architects and technologists really need to listen to. Discrete parts in our projects are combined with easily accessible fabrication technologies, such as CNC machines, for off-site manufacturing of parts, as well as an on-site manual system of assembly that uses off-the-shelf tools and doesn't require any specialist training. Now, this aspect's really important because it enables multi-generational building. In one of our most recent builds, we had local residents aged 12 to 76 as part of our building crew, and in another, 16 to 18-year-olds completed 2 weeks of work experience with us. We have also created a web-based design app in-house that allows for real-time collaboration between groups, using simple rules to communicate what is possible or impossible using a discrete system. This was developed through a co-design process with local residents as part of a larger project around the implementation of a value-centered approach for the deployment of discrete housing systems that was funded by Transforming Construction Network Plus, as well as partially by Southwest Creative Technology Network. It also, importantly, requires no specialist software, only a web browser. Now, other co-design tools that we're working with include an augmented reality application that enables real-time instructive assembly for on or off-site locations. And throughout this year, we have been testing the use of both apps with 2 sets of community members who are either local residents of the projects we are working on or work in the trades. And both groups have been people working as crew on our building projects. So the apps are really the first step in an ecosystem of tools that will expand to include platforms for tension networks and robotic control. And what this allows us to do is to incrementally automate workflows and construction processes while preserving the kinds of knowledge and labor within the communities that may use them or be affected by their increasing use. Now, recently we have worked with two communities in differing ways by taking the approach that instead of partnering with large industrial partners, we would partner with community groups and government. Both are hugely disadvantaged by the status quo in that there is a huge lack of trust on the one hand and an inability to really take risks on the other. So in the case of Knowle West in Bristol, we partnered with a community-led digital arts organization called Knowle West Media Centre, as well as their digital fabrication hub, The Factory. And I'm going to wrap up with some images of this project in a minute. And in Hackney in East London, we have been working directly with the council's regeneration team, as well as a network of partners that include cultural organizations, dance companies, theater makers, participatory artists, local colleges and youth groups, and future leaders programs, both in Hackney and in the bordering council of Waltham Forest. And what we really wish to do in these projects is provide a very different image than this for what housing production could and should look like. So by embedding production in localized settings, we anticipate the development of a coordinated network at a larger scale operating between these communities and other communities. So we set up a factory in both locations, embedded in spaces used for community groups in the case of Bristol, and a brickwork teaching workshop in Hackney at New City College. Now, in both cases, post-tensioned timber building blocks are used as the main building element. These are, as you may imagine, based on principles of digital materials and enable the reversible assembly of a structure. The timber blocks are secured by using steel rods inserted at predefined repeating connection points and are post-tensioned. The repetition of the timber elements alongside the post-tensioning generates structural integrity at almost any scale. The build of the project in Knowle West Bristol, called Block West, captured the very end of a 6-month development process in the local community, where community members joined our crew, were paid a living wage to participate, and went through, alongside us, a deep investigation via, of course, the pleasure of Zoom due to COVID, a deep investigation really into their homes, their community, and what kinds of spaces and homes they wanted, they needed, and desired. So it became incredibly important for us to show how rethinking frameworks for automation can generate the tangible and the physical. How witnessing this shift from the virtual to the tangible can embody a complete rethinking of who holds power. How it can begin to enable a culture of adaptation and resilience that holds at its core the impact that change has on communities. And what it demonstrated is that when people can identify what they contributed to a design, they can begin to start unpacking the notion of single authorship, the notion of expert, the notion of us versus them. So it also demonstrated that people, when they can identify what they contributed to a design, they can start unpacking the notion of single authorship, the idea of the expert, the us versus them. And it became so important as a way to show us how we can really construct and frame ways of working that gives an ability to reestablish trust and care in communities. So while Block West is a prototype for automated housing using a discrete housing system, it was contributed to by a huge network of individuals living in Knowle West and in Bristol, many of whom have now discovered new potentials for themselves that they didn't know that they had. So in the end, really, what it is a prototype for architectural production using automation that, yeah, can be used for building homes, but it is also a prototype for building community, for building creative adaptivity, for contributing a shared and evolving sense of place and placemaking that we hope can be scalable. Thank you very much.